Hello everybody. Today we talk about the most important part of the AI. When somebody said we made an AI model, well, model is like the input xi, this is x vector, and we have a w, this is a w I j, and we have a h vector, this is hi, and output y vector y j, and here we have a v I j, this is a v vector. Okay, so for the given input we get correct output, but we don't know anything about how you interconnect. The interconnection has a weight function. This is important for this, then weight function become large, and this is relevant to this guy, then this interconnection become 0 or very small number. Okay, so when we say train AI, basically we need to figure out this and that. So when you make a AI model in the beginning, the AI is like a baby and doesn't know anything, and you need to have a training. You have to push all the knowledge into the AI, and that's called machine learning. And until machine learning complete, AI is not usable. Okay, so it's like a baby without any knowledge. So it takes a long time to give a lot of knowledge and train the machine. So what we have to do is the h vector is going to be w vector x vector plus bias vector. Bias is a whole h will be shifted up or down, and final y vector will be v matrix times h vector plus bias again. Okay, so which part we don't know? We don't know this one, and this one, and this one, and this one. And matrix, this is a matrix, so a lot of matrix element need to be determined. So how do you determine it? So that we get for certain input we get correct output. The x is input and the y is output. For example, the x is like loan application, right? So this loan applicant history is the default, any payment in the past, income level, and other parameters. It's all part of the x vector, and the y is going to be loan granted. The loan granted with condition like a collateral, or no loan, this person is too risky. So bank hire a loan officer to do this work, review all the data about this loan applicant, and decide what to do. Grant a loan, or grant a loan with condition, or no loan. It's too risky to loan this person. So AI potentially can replace this only if we determine W, V, B, C If necessary, we make one more level, make it deep AI, right? So intermediate, H is intermediate. Remember this the previous video we talked about this intermediate. When you recognize handwriting number, instead of deciding, oh, this is a 6, intermediate stage is like, oh, there is a circle and there is a stick, and those are future characteristic detected first. From there, we decide whether it's a 6 or not. So the hidden layer sometimes help a lot to make AI very smart. What do you mean by smart? Okay, that's what we talk about here. So the machine learning, when you create it, it's a baby, and you need to have a machine learning process. It's a training. So AI is nothing without going through this machine learning. We have to train the AI. How do we train it? There are several modes of training. It's called supervised learning. And supervised learning means we have many x vector and y vector. This is like the wrong applicant in the past. This kind of applicant, wrong granted, and the result is good, or y is changed, the wrong defaulted. This result, we have a result, input, and the result. We have like several thousand of cases. Okay, so we put this into AI and change those matrix value and the bias value, so that when one of x come in, then output come out correctly. You check if it's correct or not. If it's not correct sometimes, then yi and target I, the difference, square root, and this, like a regression, this gives you how smart the AI is. Okay, if very smart, this become almost 0. For data the bank hold, say 6,000 cases, wrong cases, the AI trained, so every time you put AI xi, then yi, its correct answer come out. So this is trained, fully trained. This is called supervised learning. Okay, then banks start using this AI for wrong applicant and wrong new x data coming and yi coming, inform the applicant, okay, your loan approved. And after 1 year, it's defaulted, then this result will be no wrong. And this data is accumulated. 6,000 becomes 8,000 and become 10,000. And AI has to give a correct answer for 10,000 all the time. Well, that's very unrealistic. The AI can give correct answer for 10,000 cases. Well, if this become sufficiently small, you have to say this AI is good. If human wrong officer sometimes make a mistake, give a loan to somebody and default. So they have a success rate of loan program, say failing rate is say 1.2%, but AI gives 0.6%. Well, then bank is going to use AI instead of loan officer, right? So change the website. Anybody can apply the loan and enter the data. The bank answer right away using AI. The loan officer takes several days to review, but the AI is computer, so just give answer, said, okay, you can have a loan up to this amount and the condition so and so. Okay, so this can be automated. So bank loan program can be automated because AI shows failing rate is 0.6%. You know, this is not a science. You're dealing with people, so sometimes even exactly same data, sometimes people return the loan, or some people fail to return the loan. So you cannot have, it's not realistic to expect this difference is 100% correct, and sometimes it's fail. But the question is how much its failing rate. Okay, and so this affect the bank's insurance rate for the loan program. Okay, so that's supervised. There is another way you can think of how to train unsupervised. That means you have a bunch of I vector, X vector, and no Y vector. No Y vectors. So what do you expect? You use this when you don't have the answer. So you have a huge amount of X input. And for example, you want to find the pattern, but you have no idea what kind of pattern exists. So you do unsupervised learning. You keep feeding, and if Y becomes steady, until Y becomes steady, you keep feeding and modifying W and the V, and you find the area when Y becomes steady, and what kind of Y you expect, like a pattern. So it's like same pattern shows up, like Y1, Y2, Y3, Y4. Same pattern shows up many times. It's become steady, then you find some kind of pattern in a very large number of random data. So when you don't know the answer, you just ask AI to figure out, see if there is the answer. The AI can do it too. What you do is this steady, if Y suddenly change, then modify this and bias vectors and try to make this stable. So you need some kind of criteria. Criteria is yi minus yi plus 1 will be certain rate. If it's smaller than certain number, initially you can set the number a little bit large, and gradually you start focusing onto the steadiness. So YY, Y2, Y3, Y4 become steady. Okay, then you find the pattern. the meaning of y1, y2, y3, y4, you don't know either. So this one, you will analyze the data and figure out what this, oh, I see, this is like, you know, the person's income level. Or this one is, it will have some meaning. Then you're successful unsupervised machine learning. Now, there are semi-supervised. Learning. That means you have X vector only 1 to n and some missing, as say this is m, there's no x. Okay, and the y is going to be 1 to L. Now this data the semi-training, the self-training mode, in another word, you give all the data, X data, and get the Y. But you have additional data. When you have additional data, you give this data and this is like when expanding input data, semi-supervised can be used. You know this one to this relationship, and when you expand the input data, what happens is this may change, but target, you want to keep this target. How do you change it? You, for the additional input, you change this again. The target has to be modified. Then you extend the target, and you know, for example, loan application, you check income level, the past history, whatever, and this day you start adding some, the family number of family, and you know, the history of the job, whatever you expanded, and you have a data. You can expand this. When you expand, you kind of don't want to start from scratch. So it's a supervised mode, but semi. Only this portion supervised. Then you finish AI learning with the expanded input and output. This is like active learning. When you made a model, but later you have to add some more. You find out you have to add some more input. Then what do? You don't want to start from scratch. You use this, the same model, and from here you work on it. So it's called active learning. It's when you know, the AI is flexible AI. If you use, say, 5 years, the market tendency changed. This change is going to be incorporated in it. So that's called semi-supervised. Okay. Next machine learning is called reinforcement of learning. Or Q-learning. This learning style is like when you play chess. The chess, what you do is all your pieces has the score, and multiply the score, add them up, and compare with your opponent, all the pieces, the score, the sum of the score. And when you make a move, okay, then this relationship change. Maybe you lose. So this is a punishment. This movement is not good. But if you make certain move, your score is higher, and that's gonna be good movement, right? So you reinforce the data. That means you have X this is Y, this Y, you calculate this sum, and using this, it modify W until Y, this value becomes better. Okay, so you reinforce by penalty or reward using this reward penalty system to modify the W, so that you get most the reward, highest reward, and that's the way you think about next move. X is next move. So that's the way the AI is improved. The next move is going to be producing positive result. Okay, so that move is good with current system. If there's no move, you change X, none of them is good, then you start changing W and make sure you have a correct AI to produce the next move. So this type of learning is reinforcement. And next one is called transfer. Transfer learning. There are many different kinds of transfer learning, but only one example here is like multitask. When you are doing multitasking, and which way, which task you do first is the best way, then the benefit, the current task is transferred to the next AI, or when the market condition change, you change AI model, next model, and you start applying that. Anyway, this is again flexible AI. Okay. The last one is like pattern recognition. Actually, pattern recognition is not straightforward. You look at the brain and the eyes here, but eyes connected here, the back of the brain. And this is there is a reason when animal first time had a brain, the eye was here. So the eye moved forward over a million times, so it's become very long line here. But from here, it's pretty deep learning. The reason is this model is a linear model. This model doesn't apply for pattern recognition. For example, when you look at cup on the desk and the picture on the back, how do you recognize this cup? Well, actually, this takes several stages of non-Euclidean, they call. It's not linear. Some signal processing in engineering term, as the image has to be processed first. So there is a several stages of image processing before you feed it to AI. Okay? This several stages is all done inside the brain before AI. AI is recognitive part of the brain. Figure out what's going on here. The cup is here. Somebody left the cup here. Kind of thinking come in. But before that, the visual sense has some automatic image processing. For example, when dogs look at the things and the cat's sitting here and grass here, tree here, dog actually doesn't notice the cat. Once cat start moving, suddenly dog's brain processes it as this individual item and recognize, oh, cat is here. If cat is not moving, the dog pretty much see cat as a part of the tree, grass, and scenery. Okay? So detecting movement and detecting distance and detecting the surface condition, like it's smooth object or it's not smooth object, kind of things. There are many things detected and processed before AI can say, well, there is a cup on the table, using that matrix AI learning system. The famous story is when the person was blind since he was a baby, but his visual cortex, everything was working normal. And what's happened is they could fix the eye sight, the cause of the blocking sight. So when he was on a teenage suddenly see the world And he said, I can see, but I cannot tell what it is. For example, when he walk, there is a step, and he doesn't see as a step, so he trip. This is distance detections and stuff. This is all part of the visual recognition. And what's happened is the visual recognition has so many things. It's not linear. The data has to be manipulated. Even before AI kicks in, AI is the brain cognitive part. Before cognitive part see the data, there is a deep learning multi-stages going through, and that's the data. The abstract image is given to AI, then AI interpret what he is seeing. So this visual image graphic machine is something special in AI field. How you recognize a image. This boy, teenage boy, missed all the stage since baby starts seeing. I can see something in front of a baby and reach the hand, touch it, and learn the shape of the object and stuff. This whole process is going to create this part of the visual sense AI part. And he missed that training process, so he cannot even walk because he can see this step as a step. He just sees some line here, but what its line means, he doesn't see. Distance detection and other detection, it doesn't come into the mind, the visual sense AI. Without that, you cannot interpret, oh, there is a step, I have to move the leg carefully here, kind of things. So this process is a specialized AI field. And that's what the difficult part in auto driving. When auto driving, cameras see everything, but interpreting what the cameras see is this part. So there are a lot of non-Euclidean data processing. Non-Euclidean data processing has to be done before that the linear AI equation is brought in to interpret what it is and what to do. Is or somebody walking in front, so you have to stop the car. That's the AI. But from camera view, you have to recognize somebody walking. Is a big part of specialized AI. Okay, and this is a very big subject, and it's not completely solved as an academic subject. So there are a lot of companies developing how to do this part. Okay, so that's about it. That's a machine learning. Okay, once machine learning, it's more exciting subject about machine learning. For example, can AI create something artistic, the music or visual or whatever? This is unsupervised learning. So you set the subject, we don't know the y vector, we don't know what's the answer. But this is probably semi supervised. Start with a certain known artwork, okay, and you just objective is to make it more radical. Say this artwork is showing very sadness, and make sadness more strong and radical. That's the only direction you give, and you train the AI. The AI is going to produce very amplified sad images. Okay, so AI can create the artwork. The semi supervised is complete supervised is objective. You have to know exactly what AI has to do. But semi supervised or completely unsupervised may bring in something totally unexpected for human. And that's the area the artist usually do. Is totally unexpected, beyond normal people's the common sense, and that's AI can do. So there is an exciting subject about AI. Okay, I hope you enjoy this video, and please subscribe and click like if you want to know more about AIs. Please wait for the next video.